All right, we already looked at transcription, which is the first step of protein synthesis. Now let's go ahead and take a look at the second step of protein synthesis, which is called translation. Okay? Now translation is actually reading the mRNA instructions and putting together a protein based on those instructions. Okay? So in transcription, we made the mRNA inside the nucleus. We took the DNA instructions and we rewrote it into mRNA. So here's our mRNA strand we created during transcription. Now we're going to see what happens to that mRNA strand during translation. So the mRNA at the end of transcription left the nucleus. It goes out into the cytoplasm and it finds a ribosome. Okay? When that mRNA finds the ribosome, it's going to attach to that ribosome. And the ribosome is going to start reading that mRNA one codon at a time. Okay, so if you remember what a codon is every 3 bases in your mRNA. So 1, 2, 3, that's a codon right there. And the ribosome is going to read that in order to put together the protein exactly as these instructions say, exactly as those instructions were in the DNA. Okay? But the ribosome can't do this by itself. The ribosome actually needs help in order to read the instructions. In order to read this first codon, the ribosome needs the help from tRNA. Okay? Now, tRNA physically carries the amino acids to the ribosome to drop them off. Because if you look at the ribosome right now, there's no amino acids. And we need to connect together amino acids in order to build a protein. Okay? So the tRNA helps out. tRNA, you can think of tRNA as a helper. Okay? So to read this, the ribosome is going to look at it and go CCU. If you use your little translation chart, you know that CCU codes for proline. So if you use this, you go CCU, codes for pro, which is proline. Okay? The ribosome doesn't have a little chart like that, so that's why it needs tRNA to help. So along comes a tRNA, and tRNA comes along. It pairs with the codon. So tRNA has 3 bases on its section. These 3 bases here are called an anticodon. So that's the anticodon in tRNA. An anticodon will match a codon. Okay, so tRNA comes, C matches with G, C matches with G, U matches with A. This tRNA can drop off that amino acid. Okay? After it drops off its amino acid, it's going to float back out into the cytoplasm and it's going to look for another proline. This tRNA will only carry prolines. It will not carry any of the other 20 amino acids. It's only going to carry proline. Okay? Well, the mRNA moves through the ribosome to the next codon here. So the next codon is GUU. If you use your little chart, GUU codes for valine, VAL. But again, ribosome doesn't know that. It doesn't have its little chart to look at. So it needs tRNA's help. So a tRNA comes along, and its anticodon here matches the codon. So G with U, C, U with A, U with A. And since it matches, it can drop off this amino acid, and we've begun to build our protein. As these amino acids connect together, we're actually building a protein. Now here in this example, we kind of stop right here. A protein is not going to be 2 amino acids long. So we would actually add more based on the instructions. Okay, so if there's more instructions here, it's going to tell me exactly what amino acids to connect together. And it's also going to tell me in what order that they're going to be put together, and also how many. Okay? So once I start to make my protein by reading these instructions, that's translation. Okay? Once all the instructions have been read, at the end of the mRNA, there's going to be a stop codon. Okay? And it's going to tell the ribosome, stop right here, don't add any more amino acids, the protein is done. And if that's the case, when it gets to the stop codon, everything gets released out into the cytoplasm, including the protein. The protein is now made. Okay, so that's step 2 of protein synthesis, which is translation.